Dr. Fantasy, you can share your screen now.
Still says I can't.
Okay. Maybe you did not log in as really you really love something.
If I go out now, say participants for Gemma, then log out, then share by.
No.
Thank
So
you.
continue now. It's because you did not log in with your Unilag. You did not go through the method I asked you to do.
We'll keep getting better.
So share your screen now.
All right. So again, I'm Fatusi, Dr. Fatusi, and so we're going through some concepts. We'll be talking about errors.
If you need any of them to talk, you can just ask them to unmute. You be the one that will direct them to unmute themselves. Okay. Every other thing is fine. They cannot make noise now. I've removed all the noise. So go ahead, man. Thank you. And you are on YouTube now. So, nice.
All right. Okay. Which channel? Your channel, right?
Yes.
Okay. All right. So I'm Oluwatoyin Fatunsi, the lecturer in chemistry, and today we'll be looking at errors, accuracies, and more concepts. If not today, at least this week. And so I'll start with errors. Now, in chemistry, we take a lot of measurements. We take data. Now, when you take data, there are bound to be mistakes. These mistakes are what we call errors. There are bound to be deviations from the true value. These deviations are what we call errors. And errors could be from many sources. Could be from the instrument, or as a result of the person doing the personal error. Maybe the person, the wife, annoying the person, the man. That could, and is angry during the experiment. It could lead to, a clouded mind, and so that will also lead to error. So error can come from the analyst. It can come from the instrument itself. There are many sources of error. But in any measurement, we should be able to estimate the error. Error of a measurement can be the difference between it's usually the difference between the observed and the measured value. Between the observed, and the true value. So when you have an observed or measured value and the true value, that difference, discrepancies, deviation from the real, like I started off with, is what we call error. So when you have deviation from the true value, we say we have error. These errors could be there are different types of error. So I'll start with absolute error. Absolute error is actually the simple error of error. Absolute error, that is the actual difference between the true value and our measured value. The real error. Instead of pressing these simple errors that we do, absolute error. You know what absolute error? Your measured value minus true value. That's your absolute.
Guys, the lecturer has been logged out and she's trying to come in again. We are sorry for the disruption. Just hold on for a while. So Dr. Fatusi, you are on. Dr. Fatusi, go on.
What will be the absolute error? Yeah, look at this example. What will be the absolute error? Quickly type it in the chat box. How do we find the absolute error? And what will be the absolute error? Okay, let's just go into it. The absolute error will be the measured value, which is 22.5 minus 25.2. So is equal to minus 2.7. The relative error will be, remember your error, minus 2.7 divided by the true value. Why the percentage will be in percentage? You see the sign here, minus 11%. What is accuracy? Accuracy and precision are related, but not exactly the same thing. In accuracy, you are trying to see the nearness of a value to the actual value, to the true value. So if somebody measures something, you want to see how close that measured value is to the correct value, to the true value. While precision is referring to how close these values are to themselves. We'll be looking at real life examples. You look at these 4 readings. The first reading my cursor showing. You can say yes or no. Is my cursor showing? You see the selected one. Accuracy. You remember that accuracy has to do with how close our values are to the true value. You see how close our true values are to the true value. You see, the pink center is where the true value is, and the dots are your measured value. So you see that all your dots are within the accurate limit. So it shows that we have a case of accuracy. Why precision has to do with how close the measured values are to themselves. So you took 5 readings, you measured your value 5 times. How close are they to themselves? You see that the dots are all close to each other. So we'll say that this selected one is both accurate and precise. Let's go to this selected one now. In this case, you see that the dots, only one dot is in the center. All other dots are away. Well, but since the dots are a bit near each other, and if you do the average will still be somewhere in the center, we can say it is accurate, but it's not precise because the dots are scattered, they're not very close to each other, even though they are all close to the center. We'll say, okay, they're accurate, because if you do the average of this value, the value will be somewhere in that pink center. In this case, we'll say the data is not precise. I'm sorry, it's not accurate. It's precise, but it's not accurate. The data are near each other, but doesn't mean it's correct. It's not near the true value. The true value is anywhere near the pink center. So it's precise because the readings you took are close to each other, but it's not accurate because it's not near the true value. Why in this final case, it's neither accurate nor precise. It is neither accurate nor precise. I've defined what accuracy is. Accuracy has to do with how close your value, the measured value, is close to the true value. While precision is how close the measured values are to themselves, how well the measured values agree with each other. It's a measure of repeatability. You repeated something once, second, and you're getting similar value. So it's a measure of repeatability. How you did your first experiment is close to the second experiment, third experiment. I have another case here. Student A has this data. Student B has this other data. And student C has this other data. If the true value is 2, which student has the most precise data? Which value, which one has the most precise data? So let us see. Do your average. Do an average. So if I were you, I would say 2.001 plus 2.002 plus 2.003 divided by 3. What will it be? I'll do the same for B. I'll do the same for A. And then based on that, the one that is, which one has the most accurate? So the one that is closest to 2 is the most accurate. Which one has the most precise? The one that is close to itself is the most precise. So let's see the calculations. I've done the calculations from you. The average for student A is 1.967. The average for B is 1.970. And the average for C is 2.002. So it means that the range, the difference, this one is far away from 2 by 0.02. This one is far, the range, that is the smallest and the largest number, is far away from 2 by 0.05. And A is also far away by 0.018. So the most accurate will be the one that is closest to the one that is closest to C. I mean to 2. The one that is smallest. Which of these value is smallest? This 0.02 is the smallest value. So it means it's the closest. The one with this range. The one with this range means this one, it has the smallest distance away from 2. Because 0.02 is the smallest value of all of them here. So it means 0.02. So it means that C is the most accurate and is the most precise because its data are all different by maximum of 0.02. So that's the answer. C is the answer. Let's look at this other data. Which one is the most precise here? The most precise The most precise is this middle one. The middle data is the most precise. Which is the most accurate? This extreme data, the one on the extreme right, is the most accurate. Which one has low accuracy and low precision? The diagram on my left has the lowest accuracy and lowest precision of all of them. I have another example. All these are to drive home my point of precision and accuracy. If you look at this, if you look at this now, we'll see that who has the most precise data here? Who has the most precise data here? Can you tell me? Write the answer in the chat box. Who has the most precise data? Precise, not accurate. The most precise data here is Alice. Alice. Who has the most accurate data here? Accurate data. Faith, correct. Okay. Okay, let me take A. Who has the accurate and precise data? The most accurate and precise data is who? Faith. Accurate and precise. Who has the accurate but not precise data? Jane. Jane is accurate but it's not precise. Who has the precise but not accurate data? Who has the precise but not accurate data? Can I see your answer in the chat box? Who has the precise but not accurate data? Alice, correct. Who is neither precise nor accurate in this whole result? No level of precision, no level of accuracy in this whole data. Who is the person? Nobody's answering me in the chat box. Correct. Mary, correct. If you look at this diagram here, a contestant was shooting on a dashboard. This set of shootings, what will you say it is? Is it precise? Is it accurate? What is it? It is precise but not accurate. This set of data is precise. We are going over to stoichiometry. We want to go into the mole concept. Stoichiometry has to do with quantities of material or substances consumed or produced in a chemical reaction. So what's the amount of substance we use up or we produce by chemical reaction? All those kind of quantities is what we refer to as stoichiometry. To understand stoichiometry, we need to understand certain things. Number one, what are atoms? Atoms are very small and it's impossible to weigh a single atom. The mass of an atom can only be determined really
I think Dr. Fatosi has been logged out again. Guys, while we are still waiting for Dr. Fatosi to hook up, I want to let you know that we are going to give you tests on what you've done and what you're going to do this week and next week. So prepare for our test. I'm going to tell you the dates of the test. The message is going to be passed to you through your class reps. Make sure your class rep is on the WhatsApp platform of class reps. The message will get to you through the class rep. In addition to that, the link for the test will be sent through the same WhatsApp. So make sure your class rep is on the WhatsApp group so that when we send the link for the test, your class rep will be able to send the link to you. Again, the test is going to be on what you've done what you're going to do this week and next week. Prepare yourself. I'm going to tell you the dates of the exam. Thank you. Dr. Fatusi, over to you. She's no longer here again. I told all of them, get prepared for this course for 1 week. I've been stressing myself to get. I don't know. I will reserve my comment for that. It's almost. Let's see if she can come in another 3 minutes. Otherwise, we'll end today's meeting. But this is part of the challenges of technology. And sometimes we all need to imbibe technology. And the only one way of imbibing technology and using it well is to get good gadgets that can get good signals for you. Maybe Dr. Fatushi is still using Windows 2. When all of us are using Windows 11 now, maybe she's still using Windows 2. Windows 2. I think she's not able to come in again. 294 students, yeah. She should be able to come in. Unmute yourself, Dr. Fatusi. You are not even there. You're supposed to be the co-host. So I don't need to unmute yourself. Maybe you did not come in as Dr. Fatusi, that's why. So unmute yourself, ma. If you come in as the co-host, it's not going to ask you to unmute yourself. Go ahead, ma.
I can't share my screen. Disable share.
Because you came in as a student, not as the co-host that you are supposed to.
I'm using the same lab. I'm using the. I don't know what the problem is. I'm using the right laptop.
You are not using your line, your Unilag email, or you did not come in through Zoom. It will recognize you immediately you come in. It's going to recognize you as the co-host. I'm not supposed to be here, but because of the problem that is occurring this morning, that's the reason why I've decided to stay on. To unmute yourself.
Sorry, sir.
Sorry? If I want to log myself, I want to give you the hosting right so that I can go.
It's still disabled.
Okay, so I'll make you the host now so that the next 10 minutes you can see using for the students. So I'll make you the host now.
It's almost.
You are the host now, ma. You are the host now. Your signal is not good.
The time is almost up.
So do you want to use the 10 minutes or you want to leave it for today?
No.
Your signal is not good. You are the host now. You can share if you want to share, if you still want to teach for 9 minutes. Sorry, guys. Technology and the problems at times. So forgive us. We're going to take care of all the problems before Wednesday. Again, note Wednesday's class is 12 to 1, not 1 to 2. It's 12 to 1. Dr. Fatusi.
Sir,
Go
I'm
ahead.
here, but I don't know what's happening.
You are the host now.
Yeah, I am.
They can see your screen now.
My screen is not sharing. They can see it. Okay, if they can see it, I will
saw
use
it
because I can't see it sharing. All right.
But it has,
Okay, so
we saw it few seconds ago, but it has disappeared again.
My dear,
just go back to share screen.
Because me, I don't know what is happening.
Okay, girls, go ahead, but your signal is bad.
I did it so, and it's not. So what is sue me?
Go ahead.
I'll just teach without the sharing screen, and they will have the slide after this lecture.
Yeah. Can I send the slide to them today?
So for you to, okay, so I was trying to, so we have please send it to them right away, please. Thank you, sir. So I told you that because you cannot measure relative to something else experimentally, and that standard we measure that atoms relative to is carbon 12. Carbon 12. Carbon 12 is assigned a mass of 12. So this provides us a standard for which we measure all other atoms. And the equipment we use when measuring other atoms is called the mass concept. We need to understand the average atomic mass times is given 12.01 instead of 12. I've also said that when you see some average atomic masses of certain elements, you see it with having some decimal numbers attached to it. As in the case of carbon, you see that 12.01 and all of that. You see chlorine is number. What we have is called average atomic mass number. Instead of relative atomic mass number, we have average atomic mass number. Well, I have an example here, but I know you can't see my screen. You can take the notes down, take it down. 12 carbon, that's carbon 12, has a 8.89 and carbon 10%. Did you get my question? Of 98.89% and 10.1%. What will be the average atomic mass? To calculate the average atomic mass, you take note of the percentage, as in the other case was 98.89. So you express it as percentage, so 98.89 divided by 100. times 12 because it was carbon, it was 12 plus 1.11 divided by 100 times 13 as 12.01. If you didn't have isotopy, you would have seen it as 12.00. But because of isotopy, it's having the average atomic mass as 12.01. I have another example, which will be you'll find in the slide that will be shared to you. The atomic mass the atomic mass of chlorine 35 is the atomic mass of chlorine 35 and chlorine 34 are 34.96 and 36.956 75.53% and 24.47%. This is their abundance, 75.53 and 24.47. I guess you can see my window now. Can you all see my window?
Yes, they will be able to see.
Oh, you can see it. Everybody can see it. Okay. That's good news. Okay. So I continue. This is the example I tried to explain before. We wanted to calculate that you have relative atomic for average atomic mass. An average atomic mass takes into cognizance the percentage, the abundance in nature, as seen in this case. Carbon 12 has an abundance of 98.89, while carbon 13 has an abundance of 1.11. And then we've done that. When you do that, if you follow this, you get an relative atomic mass of 12.01. And I gave another example as seen here. You see the abundance of chlorine 35 is 75.53 and the abundance of chlorine 37 is 24.47 and their relative atomic masses are 34.968 and 36.956. So we need what will attach to chlorine is actually the average atomic mass, and to calculate the average atomic mass of chlorine, just like what I did, the example I gave before, percentage abundance over 100 times its own relative atomic mass plus the percentage abundance times its own relative atomic mass, and so you get your answer will be as seen there, 35.45 if you compute this. Now, another concept we need to know about is the Avogadro's number. Avogadro's number helps and the mole concept. Now, because samples contain so many atoms, a unit of measure is called the mole. A unit of measure is called the mole. Just imagine in a grain of rice, and you can use module, you use derica, unity of rice or gari. Yeah, take so cumbersome to measure. But if you say I want a derica of gari or a paint pail of gari or you know, this module or different things of Gary, particular measure of Gary is doable. That's what's happening here. Atoms, there are so many tiny atoms. So one to refer to a measure of atom, we use mole. Mole is what is being used to count atom. A mole, what is a mole? A mole is an amount of substance that contains as many atoms, molecules, or particles as there are in exactly. You know, when we talk about a derica of Gary, you can use derica to measure Gary. You can use derica to measure that can be used to measure any type, I mean, atoms, molecule, or particles. It's used for measuring them. It's a measure. The units are already, so I have to stop. We'll take it from here. I hope in place to ensure that I'm not being logged out as frequently. We've gone away with something. We started with errors. You can explain precision and accuracy and average atomic mass. And of measure for atoms is about exactly the amount of 12 grams of